How to find hardness of water by EDTA titration. The aim of this experiment is to determine the temporary and the permanent hardness of water by a titration with EDTA. We need to find some materials and chemicals for these two experiments. All the materials and chemicals are listed here, and this is the experimental setup. We carried goggles to protect our eyes through the experiment, and I will explain what we did. After finding all the materials and chemicals, we were ready to begin the experiment with tap water. To prepare the second experiment with boiled tap water, we boiled 1 liter of tap water in a kettle, while the boiled water must cool down to about 35 degrees before we can use it for the experiment. We did that because it's best to process them at the same temperature, otherwise you will have to convert the results later. First, we filled up the burette with EDTA titration about 0. To make it easy and the calculations exact, we zeroed the burette so the EDTA titration line was accurate on 0, as you see right here. Then we measured 50 milliliters of tap water and placed it on the magnetic stir with heater and added a magnet and the 2 milliliters buffer. Then we added the thermometer, as you see right here, and turned on the heater and warmed the mixture carefully up until it was about around 35 degrees. And this time it was 34.2. After, we took 1/3 teaspoon of the indicator Aerial Chrome Black Tea and added a little thyme into the conical flask, so the mixture turned pink. This is without EDTA in. When we got the right color, we started to add the titration with EDTA and dropped it slowly until the mixture turned purple. As you can see here, we have used 18.5 milliliters EDTA. We noted the volume of EDTA on a paper, so we remember it to the calculations later. After that, we added more EDTA to the mixture till it turned blue, and we end up using 27.4 milliliters. In some cases, you need to refill the burette with EDTA and zeroing it again. As you can see in the video, we see the color changes. The mixture starts pink, and the more EDTA we add, it's turned purple right here. And we add more EDTA, so it turns blue. This is the colors of the mixture in the boiled tap water. This is the start, and this is when we had at 16.2 milliliters of EDTA, and this is the mixture's color when we have at 18.5 milliliters. So we got this tap water and then add the indicator Aerial Chrome Black Tea, which bonds with the calcium and magnesium ions. But when we add the EDTA titration, will all the calcium and magnesium ions bond with the EDTA instead of the indicator. The indicator makes the mixture a color, but it doesn't bond with anything. So if we didn't add the indicator to the water with calcium and magnesium ions, but just add EDTA, like this, the mixture wouldn't change color as we see through the experiment, because the tap water and EDTA titration both are colorless. The liquid starts being colorless, then we add the indicator and it becomes pink, and because the calcium and magnesium ions bond to the indicator. Therefore, the more EDTA you add, the more will the mixture become purple or blue. When there isn't any calcium or magnesium ions in the mixture, is the mixture becoming blue. I have made some calculations for the experiment with tap water, and we got the volume of the tap water, which is 50 milliliters, and we got the volume of EDTA, which is 27.4 milliliters. And because it's and we calculate the volume of EDTA from milliliters to liters because it's much easier to calculate with. So we divide it with 1000, so it's 0.0274 liters. Then we calculate the amount of EDTA by isolating N in the formula C equal to N divided with V. So it's N equal to C times V, as you see. And by adding the data from this experiment, it's giving the result 0.0000274 mole. While we know the ratio is 1 to 1, the amount of calcium and magnesium ions are equal to the amount of EDTA, which is equal to the amount of calcium ions, which is equal to the amount of calcium oxide. And because the water hardness determines by looking at how much calcium oxide the water contains per liter, then we need to calculate the molecular mass of calcium oxide by looking it up in their periodic table of elements. We found these numbers. And it's 56.077 grams per mole. After that, we need to calculate the mass of this calcium oxide with the formula M equal to N times N. And by adding data, we get the result 15.4 milligrams calcium oxide in 50 milliliters tap water. And now we want to know how much calcium oxide there are in 1 liter tap water. So we say 1000 milliliters divided with 50 milliliters times 15.4 milligrams, which is 307.3 milligrams calcium oxide in the water, in 1 liter tap water. And now we know we want to calculate the water hardness, and we said it's 307.3 milligrams calcium oxide divided with liter per liter divided with 10 milligrams calcium oxide per liter per degrees hardness. Because this is 1 degrees hardness is 30.7 degrees hardness, so the result is very high, and that means that the water is really hard and contains a lot of calcium ions. I did exactly the same calculations with boiled tap water, just another volume of the EDTA. I have compared my results with my local waterworks, and they had analyzed the water, and it said that the water in my local area is rather hard, about 12 to 18 degrees hardness. And compared to my results, it seemed like something went wrong in the experiment. Either the indicator has failed, or the concentration label of the EDTA bottle has not matched the concentration of EDTA in the bottle. And the tap water in Denmark comes from the subsoil water, and this subsoil water is brought up to the surface with some of the metals from the soil, and in some parts of Denmark there are a larger amount of calcium ions, which makes the water harder. We assume that the degrees hardness is 1, and their calcium ions plus magnesium ions is 1.78 times 10 in minus 4 molar, but must be proven. 10 milligrams per liter is equal to 0.01 gram per liter, and we used to find the amount of calcium oxide, and therefore use the formula N equal to M divided with M. and by adding my data from the experiment, we get the result 0.000178 mole per liter, while the unit is per liter. While we know the ratio is 1 to 1, we divided the result with 2 to separate calcium and oxygen. And that's give us the result 0.00008915 molar. To prove the assumption, we must add the concentration calcium and magnesium, as you see on the screen right here. So 0.000178 molar is almost the same as 1.78 times 10 in minus 4 molar. As we can see at this map, we can see that there are differences of the water hardness in Denmark by looking at this map right here, and we can find the salt water in the middle of Jutland, and we can see that around the capital Copenhagen, we got extremely hot water, and the water hardness is different because it depends on the soil. And there is a substance of EDTA added in the detergent to bond with the calcium and magnesium ions to prevent precipitation on the clothes and inside the washing machine. So if the water is very hot, you need to add a lot of detergent to get the clothes clean. Thank you for watching. I hope you enjoy.